Hi guys, this topic is all about RMS value of AC circuit. In an alternating current circuit, RMS is the same to the value of the constant direct current that produces the same power dissipation. Next, we have these two images. The first image is a circuit of constant 5V DC and 5 ohm resistor load. The power dissipated in this circuit is equal to the power dissipated in the image 2, since the value of the voltage is given in RMS. The graph of a 5V DC is shown here, straight horizontal line. And to get the power dissipated, we have the formula P is equal to B squared divided by R. This formula is applicable in the image 2 if the voltage is in RMS value. For an AC signal, the sine wave will be like this. The Vrms is located below the maximum or peak value, and this point here is the maximum voltage or peak value of the AC. To solve for the peak voltage, we have the formula Bp is equal to square root of 2 Vrms, or approximately 1.414 Vrms. So the peak voltage of the image 2, which the given is 5V Vrms, is equal to B peak is equal to square root of 2 times 5, which is equal to 7.07 volts. 7.07 volts is the peak voltage of 5V Vrms. Don't be confused if the peak voltage is given, then you have to calculate first its Vrms. To get the Vrms, guys, just use the formula, which is B peak is equal to square root of 2 Vrms. And by manipulation, Vrms is equal to B peak divided by square root of 2. To simplify, guys, we can rationalize the formula, then we will have Vrms is equal to square root of 2 B sub P divided by 2, or Vrms is equal to 0.7071 B sub P. I will show you on how to solve or where do we get the value of 0.7071. So guys, we have a given graph, a sine wave. Let's say we have the peak voltage which is equal to 1 volt. So the Vrms is equal to 0.7071 volt. In this graph, y-axis is the voltage V and the x-axis is the t in radians. The total of one cycle is equal to 2 pi. The half cycle is equal to pi. The function we will use is b sub t is equal to sine of t. So to solve for the RMS value, we have to take the half cycle of the graph, which is shown here. After we take the half cycle, we have to divide it by 4 equal parts. Here we will have 1 pi over 4, 2 pi over 4, 3 pi over 4, or 4 pi over 4. After that, we will use the function b sub t is equal to sine of t. So for number 1, time t is equal to 1 pi over 4 or pi over 4. To solve the voltage, we have sine pi over 4 is equal to 0.7071 volt. Then the square of the voltage will be 0.5. For number 2, guys, the time t is equal to 2 pi over 4 or pi over 2. To solve the voltage, we have sine pi over 2 is equal to 1 volt. Then the square of the voltage is equal to 1. For the number 3, guys, the time t is equal to 3 pi over 4. To solve the voltage, we will have sine 3 pi over 4, which is equal to 0.7071 volt. Then the square of the voltage will be 0.5. So for number 4, guys, time t is equal to 4 pi over 4 or pi. To solve the voltage, we will have sine pi, which is equal to 0. Then the square of the voltage is 0. So to solve for the RMS, guys, we will have RMS is equal to square root of the summation of B squared divided by the number of voltage squared. Using the 4 voltage squared we solve, we will have square root of 0.5 plus 1 plus 0.5 plus 0 divided by 4, which will be equal to 0.7071. Guys, remember the formula. Vrms is equal to 0.7071 Bp. and BP is equal to VRMS divided by 0.7071 or equal to square root of 2 VRMS. The general formula for VRMS is equal to square root of 1 over t, the integration of b squared of t dt from 0 to t. Time t is equal to pi since we are going to integrate the half cycle. So the solution, guys, is VRMS is equal to square root of 1 over pi, the integration of sine squared t from 0 to pi, since base of t is equal to sine of t. I will not explain on how to manually integrate the equation. Using the calculator, we have the square root of 1 over pi, the integral of sine squared x dx from 0 to pi will result to square root of 0.5 or square root of 1/2, which will be equal to 0.7071. So guys, those are the two ways on how to solve the value of RMS.